Transformer losses are the various forms of energy dissipation that occur in a transformer during its operation. These losses affect the efficiency of the transformer and result in energy being lost as heat, sound, or other forms. Losses in a transformer are typically categorized into two main groups: no-load losses, core losses, and load losses, copper losses. In electrical power systems, transformer extra losses by harmonics refer to additional losses in transformers caused by nonlinear loads that produce harmonic distortions in the power system. Harmonics are voltage or current waveforms at integer multiples of the fundamental frequency, e.g., 50 Hz or 60 Hz. Nonlinear devices, such as computers, variable speed drives, and other electronic equipment, often introduce these harmonics. Core losses, no-load losses. These losses occur even when the transformer is energized but not supplying any load. They are primarily due to the magnetic field in the transformer core. Core losses are divided into the following types: hysteresis losses, caused by the repeated magnetization and demagnetization of the core material as the alternating current passes through the transformer. Dependent on the material properties of the core and frequency of operation. Proportional to the area of the hysteresis loop of the core material. Eddy current losses. Induced currents. Eddy currents are generated in the transformer core due to the changing magnetic field. These currents circulate within the core and cause heat, leading to energy loss. Proportional to the square of the frequency and the thickness of the core laminations. Reduced by using laminated cores with thin sheets to minimize eddy currents. Copper losses, load losses. These losses occur due to the resistance of the transformer windings when current flows through them, typically under load conditions. Copper losses vary with the load on the transformer. I-square are losses, winding resistance losses, caused by the electrical resistance of the transformer windings. Proportional to the square of the current. I-square or vary with the load current. Higher loads result in higher copper losses. Stray losses, losses caused by leakage flux, magnetic flux that doesn't follow the intended path, linking with structural components such as the tank, windings, and other parts. These losses result in circulating currents and eddy currents in components other than the core. Stray losses in structural parts. Stray losses are a category of additional losses that occur in various parts of the transformer, especially when operating under harmonics or high currents. These include tank losses, losses due to eddy currents induced in the transformer tank or enclosure by the leakage flux. Clamping structure losses, losses due to the magnetic flux linking with the clamping structures that hold the transformer windings in place. Losses in winding conductors due to harmonics, caused by harmonic currents that flow in the windings.